Hey guys, welcome back. So this lesson we're going to be working on work again, and I'm going to write this like very difficult example. So for you guys to have a think how we can use this. Okay. So this is as difficult as they can be. It will not be any harder than this. In fact, I don't think any NCA level one question will be like this difficult. So, but even though it's a difficult question, but we got all the tools and concepts and information equations we need in order to solve this kind of problem. Okay, so I want to just run it with you guys. So it's in your notes that I posted out. So. You can have a look at that as well. Okay, so let's have a look. This situation is we got a person over here that's gonna go down the slide. Okay, so we got a few information here. One is we know that this height is going to be 3 meter and the length of this thing coming down is going to be 6 meter. Okay, 6 meter over here. And then you got a friction going backwards, which is 100 Newton. So, oh, can't see very well. Yeah, okay, sweet. So the friction is going to be 100 Newton going backwards and the mass is going to be 50 kg. Right, so that's it. That's 1, 2, 3, 4. 4 information that you know over there. And then they're gonna ask you, well, what is the speed of this person gonna be at the end? Okay, so this is quite a difficult question. We have to take step by step. So sometimes with a question, you don't know how to get the end answer. Okay, so straight away, but you just have to according to it's like a puzzle. Okay, you know this part, then you can get this one. And once you know this one, you also know this one, then you can get this one. And then slowly you move back to the end. Okay? All right, say for the example, this question. Or sometimes you can say, well, this is what the question is asking me. Well, in order to find that, I have to know this. And in order to know this, I have to know that. So you can go from the beginning this way, you can go from the end this way, and then hopefully somewhere it's going to meet in the middle, and then you can solve the problem. Then you get from this part and then all the way to this part. Okay? Right, say this question is a typical example of that. Let's say this. I'm gonna have a quick look of the end over here, okay? It wants me to find out what the speed is. Okay. If they ask you about speed, if you've done enough questions, then you will know that okay, if I can know the kinetic energy, then I will know speed. Because kinetic energy is gonna equal to half mv squared. Right? If I know kinetic energy, I know the mass, 50 kg, and then I can find out speed. Well, that's one way of doing it. Or you can say, oh yeah, is there going to be acceleration or is there going to be a constant speed? So you go down that track. But in this particular question, that track will not work because you don't know the speed and you don't know acceleration and how much time it's going to take. So it's going to be very difficult. So this question we can think of, okay, so can we find kinetic energy? Okay. All right, if we find kinetic energy, well, we go backward. Where does this kinetic energy come from? Right? So if I know where it comes from, I can find out how big it is. Okay, so let's come back over here. So the kinetic energy over here will equal to the potential energy. It's coming from the potential energy coming down, right? So if there is no friction, we can this is just a typical example we've done before, which is gravitational potential energy turning into kinetic energy over here, right? But now there is a friction. So how is the friction is gonna play in there? Well, friction is gonna turn some energy into heat from the lesson we've learned before, because friction is gonna do work to turn energy before. Okay, so now I can have a thing. Well, originally I had EP, and some of the EP is gonna turn into heat. If some of it has lost to heat, and then the leftover is gonna be my EK. If I can find out the original gravitational potential energy, that energy, some of it is going to turning into kinetic energy, lost as heat, and then once it's lost with heat, and then the leftover will be kinetic energy at the bottom, and then that kinetic energy will be able to turn into speed. Okay, all right. So now let's have a look. So gravitational potential energy is going to be mgh. So let's have a look over here. mg, which is 50 times 10, and then times the height, which is 3 over there. So that gave me 500 times that, 1,500 joule. That is the amount of gravitational potential energy we have over here due to the height. Okay. All right, and then the next part is we're gonna find out how much heat is. Well, heat, where does heat come from? Heat is gonna be friction doing work. So it's actually just the work done by friction that equal to friction times the distance friction is working. Okay, let's have a look. How big is friction? 100 Newton. And then how big is the distance? This is something you have to think about because we got two distances over here, 3 meter and 6 meter over here. So which distance should be the one you're using? Should be the 6 meter because that is the distance in the direction of the force moving, okay? All right, so it should times 6. That gives me 600 joule. So total gravitational potential energy was 1,500, and then now 600 turning into heat, and then we put in here. That gives me 900 joule of kinetic energy. Okay, so now we're gonna put it over here. 900 joule equals to half times the mass, which is 50, and V times V squared. Okay, I can rearrange that. That becomes 1,800 divided by 50. That equals to V squared. So V squared equals to 36. Speed equal to square root 36. That gave me 6 meters per second. Okay, you can see this question. It seems to be a very difficult question. I mean, it is a very difficult question. It's as difficult as it can be at this year level. But if you break it down to steps, say if you can think, well, to know speed, I need to know kinetic energy. To know kinetic energy, I need to find out where does the kinetic energy come from. It's the gravitational potential energy turning into kinetic energy. Then, however, there's some energy is going to be lost as heat. So if you can break it down into these little steps, so that should be able to help you to solve this kind of difficult question. So in your homework book, so most of the questions, they've already break it down for you. So you just need to break down one step by one step. But I just want to run this most difficult question for you so that you get a kind of understanding. If you do encounter a difficult question, that is the kind of thinking you need to go through your mind, and then in order to solve this kind of problem. Okay. All right. So for the homework, if there's any question, just send me an email. If you're struggling with the questions, probably some other student will be struggling with it as well. So send me an email, and then if there are some questions I think quite important, as always, I'm gonna make another video for it, so that will be able to help you guys in the next couple of weeks when you are studying at home. Okay. All right. Have a good day, guys. Stay safe, and see you in the next video.